In this video, I'm going to show you how you can set up your own bare metal STM32 project without using vendor-specific tools or libraries. We'll be working directly with SimSys, using vendor-supplied header files, a linker script, and a startup assembly, and open source tools as well. The first step is to download the GCC ARM compiler, which you can find on the ARM website. The next thing is to download the SimSys folder, which you can find in the repository for your microcontroller. In this case, I'm using the STM32 G431KB microcontroller, and there's a repository here where I can find the SimSys folder. So what you should do is go to drivers, and then this SimSys folder is what we are going to use. So that's what we are going to add to our project. It contains all the SimSys implementation files and header files and everything that we'll need to compile our project. We would also need the linker script, and for that one, you should follow this directory in the GitHub repository to STM32CubeIDE and then copy this linker script. You can either open it here, copy it raw, and then paste it in your text editor and save it locally, or you can clone the whole repository, this whole repository, and then copy this file into your project's directory. So as you can see here, I've copied both folders into my project. I have the SimSys, and then in the linker repository it contains the linker script, so you can see that right there. So you have to find the GitHub repository for the microcontroller you're using. In my case, I'm using the G431 microcontroller. If you're using an F1, you'd have to also find the F1. So you can basically Google the name of your microcontroller. If it's an STM32 microcontroller, you go to their website, and then it will show you where the GitHub repository is. You can clone the repository locally and then copy this SimSys folder and this linker script and put it in this linker file here. The next step is to set up our CMake list file. So we create the file, create the file, and then you can open it in your text editor. Yes. And to get the contents of the file, I created a tool that you can use to generate code, which I'll show you. So this is the tool. It's very basic. I'm still working on it, but you basically select the microcontroller you're using. For now, I just have this, so I'll add other microcontrollers down the line. If you have a favorite microcontroller or one that you work with a lot and you want me to add the boilerplate code for those microcontrollers as well, you can mention them in the comments and I'll work on adding them as well. So you go to this website URL, select the microcontroller. In this case, we are generating a CMake list. So this is the code here. You copy this and paste it in your project. So I'll just go through this briefly. We set a minimum version for CMake. We create a variable to hold the name of the project. In this case, we're calling it demo, and we are using C and assembly. We're using the C11 standard, and then a very important one is, at least I'm using Vim. This line 8 exports the compile commands into a JSON file, and it helps CMake do its LSP stuff. So, code completion and all that, all those nice stuff that you need to help in the development process. And we set some flags for the compilation as well as the linking. And we add this definition because in the STM32 header files, you have to define which exact microcontroller you're using, because there are so many different microcontrollers in the STM32 G4 range. So if you are using F1, there are so many microcontrollers in the F1 range. You have to specify which exact microcontroller you are using, and then we're going to start off with using creating just one main file, since it's more of like a setup project. So it's going to be really simple. So I guess it's just going to have a main.c, and these two lines here are really important from the Simpsons folder we copied. Right. You have to link these two as well. This assembly code as well as this startup C code. Yeah, so make sure that you add those. Whereas at least it's in the, if you copy the code from the code generator, it will be added for you, provided you copied exactly your Simpsons folder and pasted it in your project. One thing you should watch out for is this line here, or at least, yeah, because this is also dependent on a microcontroller you're using. So if you are working with an F1, it will most probably be, it will be F1 here instead of G4. So F1 instead of G4. And you include directory. So we are going to have a root directory called include that will have all our header files in. In this project, it's quite similar, so we wouldn't have an include file. We wouldn't have any include files or header files. We just work with main.c. But in coming tutorials, I'll be making more complicated ones where we'll need this. And then you also include from your Simpsons folder as well. And okay, so for this one, is in our case it's optional because we are not going to be using any of the C libraries, the standard libraries. In case you needed to use like C standard libraries in your embedded project, then you can link this project to it. But in our case, we are not, so we can comment that out. It's safe to do. And we have some post build commands where we run at the end of the compilation to generate the bin and elf files. Yeah. So this is a brief overview of how the CMake file will look. As we keep adding folders and files, new files, source files and stuff, we'll keep populating this. The next step is to create a toolchain file, and basically we need this toolchain file because we are working with a cross compiler. The project that we are going to compile is not meant to run on the PC or computer we are using to write the code. So we can go ahead and create that, give it a very good descriptive name. And we can look for it here. And I just realized I've not included it in my the code generator I have. I'll include this as well to make it easy for you to follow along with this. But basically this is the code. So what we do is that we set the processor type as ARM. So you set the compiler you're using for this project. In this case, it's the ARM GCC compiler, which we downloaded at the beginning. You set that one for C compiler, the assembler as well, and the object copy, object dump, and the size. All these binaries that we would use in our compilation process. And we add these 3 lines as well to avoid using the whole system paths. So this is how your toolchain file will be. So I run the build command following this. So you have to give it the path to your toolchain file as well. We set the source as the current directory, and then we set the build directory as a build. Should call the build directory build. So we run this, and it says I can't find main.c. So what we do is we CMake. We can take this off for now. When we do this first CMake, then we can build that. Okay, so now I've been able to set that up. So our first step is to create a directory for our source files. I'll call that src, and then we can go into src, and then we'll make a main.c file. So once we do that, we can now edit our CMake. Oh, I forgot to go back. And Vim CMake, yeah. So now we can add this. And because you've added that, it's a good idea to, because if you check your root, you see that the build directory has been created. It's good idea to like clear it, right? And then rebuild your CMake project again, right? And everything is built nicely. So now we'll go to our main.c file, which is where most of the action is going to happen.